This is the third section of chapter 2, Quadratics, and this section is all about functions. So what is a function? Well, in mathematics, a function takes an input value, does something to that input value, and then gives you an output value. Now, it may be a single value that goes in, it may be lots of different values that go in, or it may be all values that go in, all types of numbers, any number that can go in. And we do something to those numbers. That could be squaring them, multiplying by 3, taking away 2. It could be anything, find the power of those numbers, and then we get a set of output values. Now, the notation that we use and the words that we use the word domain to represent all the values that can go in, f of x to represent what the function is, and the range as the set of output values. So input is domain, output is range. I can also represent what's going on a graph. So here I've got a part of a graph generated by the function f of x, and the domain, the set of input values for this part of the graph, are basically the x values that go in, and I can represent the domain this way. So these are the input values here that are going into the function. They produce the graph and show us what the output values are. So between the same input values, I can see where the output values are, and that gives me the range. So it is possible to find the range and the domain of a function by looking at the graph of that function. Now, if the set of input values, or the domain, or the set of output values, the range, can be all real numbers, then this can be represented by the symbol R. So first of all, what do we mean by all real numbers? What are real numbers? Well, these are all of the integers, positive and negative, so whole numbers. This is all of the fractions, so every single fractions, positive and negative as well. Surds, so any surds. Rational numbers, so these would be things that can be written as fractions. And irrational numbers, so numbers like the square root of 2 or pi, so numbers which have an infinite number of decimal places with no repetition. They would be recurring decimals, and those recurring decimals can be written as fractions. So this is all types of numbers that you can think of. These are real numbers. So if my domain, my set of input values, was every single number, I'd write it like this. So X stands for domain, numbers that go in. This symbol here, like a rounded E, means in the set of, and then R means real numbers. So if I say all of this together, this is the domain can be or is in the set of all real numbers. So basically, any number can be my input number. And then if I want to show that my domain, range, can be any real number, so any number can be the output number from a particular function, then I'd show this. So this means basically the function, the output numbers, the range is in the set of real numbers. My output can be any number, any real number. Now there are other sets of numbers as well. I'll just tell you these out of interest. You don't need to know these for A-level maths. A couple of them you would need to know for further maths if you study further maths. So C stands for complex numbers. So if you do further maths, you'll learn all about complex numbers. Z, Zahlen, that's the name of the letter in German. This stands for the integers. So these are all the whole numbers, positive and negative. N stands for natural numbers. So these are the counting numbers. So these are positive integers. And Q stands for quotient. So these are the numbers which are written as fractions. Example 8. The functions f and g are given by f of x equals 2x minus 10 and g of x equals x squared minus 9, and x is in the set of real numbers. So what this means is the input values can be any type of number: positive, negative, 0, whole numbers, fractions, rationals, irrationals, surds. So any type of number can be our input number. That's what this little bit here means. And in part A, what we need to do is find the values of f of 5 and g of 10. So we'll start with part A. F of 5, so the number in brackets is your input value. So we put that input value into our function 2x minus 10. So that will be 2x, which is 5, 2 times 5, that's our input value, minus 10. And we're going to work out the output value. So that will just give me 10 minus 10, which is 0. So when 5 is my input, 0 is my output. And then the second one, where we have g of 10, so 10 now becomes the input value, the x value, into the other function, x squared minus 9. So replace the x with 10, so 10 squared minus 9, that's 100 minus 9, and that's going to give me 91. Part B, what we need to do is to find the values of x for which f of x equals g of x. So we want to find when f of x, 2x minus 10, is equal to g of x, and g of x is x squared minus 9. So what I'm going to do is just rearrange it so it's in a form of some sort of equation which I can solve. So there's an x squared there, so it's not about sort of taking away x from both sides or adding something to both sides. I'm going to rearrange this so it becomes a quadratic. So I've got x squared, well, it's currently a quadratic, but I want to write it in the form where I can solve it either by factorising, use a quadratic equation, or maybe even completing the square. So x squared, and then take away 2x from both sides, minus 2x. So I've got negative 10 here. So if I add 10 to both sides, effectively bring that over here, I will then have plus 1 equals 0. So this is now in a form which I can solve, or it's going to be easier to solve. I'll try factorising first. So I'm looking for two numbers that multiply to give me 1 and add to give me negative 2. So those two numbers are going to be negative 1 and negative 1. So my bracket is going to be x minus 1 and x minus 1, which I could also write as x minus 1 all squared. So either form is going to be easy to solve. X needs to be 1 in either case to solve that. So x is equal to 1. And there's only one solution which is consistent with the question, because it says the value of x. If it said values, I'm guessing that I'd probably be looking for more than one value of x as my solution. Example 9. The function f is defined as f of x equals x squared plus 6x minus 5, where the domain is all real numbers. Any number can be an input number here. Part A, write f of x in the form x plus p all squared plus q. So we're completing the square in part A. So f of x is equal to x squared plus 6x minus 5. So from here, what we'll do is we'll say f of x is equal to x plus, now we want half of the number in front of x, the coefficient of x, which is going to be 3. So we have x plus 3 all squared, we're halfway there. Now, when I expand these brackets, I'll get x squared, which is what I want, plus 6x, which is what I want, plus 9. But I don't want plus 9, so I'm going to subtract that 9. But I do want the number negative 5. So I'll put negative 5. So as I've done before, I take off what I don't want, and then I add on what I do want. And what I do want here is negative 5. So from there, I can write f of x is equal to x plus 3 all squared, and then minus 9 minus 5 is minus 14. So I'll just write what my values of p and q are. So p is equal to 3 and q is equal to negative 14. Okay, we'll just highlight that. And then we'll move on to part B. Now part B, it says hence or otherwise find the roots of f of x, leaving your answers in third form. So if we're going to find the roots of f of x, that means solving f of x. So the roots are always when the function is equal to 0. This is where the graph crosses the y-axis, sorry, the x-axis, the roots of an equation. So what I'm going to do is make f of x equal to 0. That means I'm going to make x plus 3 all squared minus 14 equal to 0. And I'm going to rearrange that and make x the subject. Now when you see a question and you see the word hence, it's normally a clue. It's saying use what you've done previously to help you, or you can start from scratch. That's what the otherwise means. So or otherwise means start from scratch and don't use what you've just worked out. Hence means use what you've just worked out. Now the easier way is the hence part. Use what we've just done. So I'm using the completed square form of f of x to help me find the roots. Otherwise would be I go straight back to what I started with and somehow use that to find the roots. So I could have used a quadratic equation to find the roots from here, or try to factorize it. But since we've completed the square, that's always the easier way. Use what you've just done to help you. So what we're going to do with the pen, not the highlighter, is rearrange this to make x the subject. So we have x plus 3 all squared is equal to 14. We add 14 to both sides. Square root both sides. X plus 3 is equal to plus or minus, always plus or minus, root 14. Now root 14 can't be simplified in any way because it's just 7 times 2. Neither of those are square numbers. Then from there we will take away 3 from both sides. So x is equal to negative 3 plus or minus root 14. So our roots are going to be x equal to negative 3 plus root 14 and x is equal to negative 3 minus root 14. We leave them in third form. We don't change these to decimals because the question said leave your answer in third form. Part C. So what we need to do in part C, it says write down the minimum value of f of x and state the value of x for which this occurs. So what we're going to use is the completed form. So we want to find the minimum of f of x, which basically means finding the minimum of our x plus 3 all squared minus 14. Now this part of our completed square form is going to be something squared. This is never going to be negative, the whole thing, never negative. The smallest it can ever be, the lowest it can ever be, is 0. So smallest is 0. It can't be negative, it can be positive, but the smallest is 0. So when this part of the completed square form is 0, that's going to give me the minimum value of the whole expression. So let's just write that down. So when x plus 3 all squared is equal to 0, the minimum of f of x is going to be negative 14. We can't go any lower than negative 14. We can get bigger than negative 14, but never lower than negative 14. So when is this whole thing going to equal 0? Well, it will equal 0 when x is -3. So when x is equal to -3. When x is -3, you'll have -3 plus 3. You'll have 0 squared, which is 0. So we now got the bits we need for our answer. So the minimum is -14 when x equals -3. We needed to state the value of x at which the negative occurs. So the smallest the whole of this quadratic could ever be is -14, and that will happen when x is -3. So if we were sketching that quadratic, then what we would have is the lowest point of that quadratic. We're going to sketch it maybe something like this, and that minimum y value would be -14, and the x value at which that occurs would be at the number -3. Example 10. Want to find the roots of this function, x to the power 6 plus 7x cubed minus 8. Now some people are going to look at that and panic and not realise this is almost like a quadratic. It is like a quadratic. How? Well, there's some patterns here. Can you see that with these powers, if I take that power of 3 and times it by 2, I get the power that's on the first term. So that's the first thing that I noticed, that this power here is double this one. So it could be that I've got powers 4 and 2, or 8 and 4, or 10 and 5. So there's a pattern in that this power is double this one. And the second thing is that the last term has no x, so there's no x. Whenever we get an expression or equation that looks like that, we can use the same techniques we use with quadratics to complete the square, to find the roots, the same things that we do with quadratics. Now, how do we do that? Well, what we do, I'm going to think of that function, x to the power 6 plus 7x cubed minus 8. I'm going to write it like this: x cubed squared plus 7x cubed minus 8. So maybe you can see what I've done here. This looks like a quadratic. I've got something squared plus 7 times something minus 8. Another way of thinking of it is like this. If I said let y equal to x cubed, then I could write this function in terms of y as y squared, because it's going to be x cubed squared, plus 7y minus 8. Now this will recognise as a quadratic. So we could use this form, solve this, and then realise that when we solved y, that y is actually equal to x cubed. I'm going to do it this way because this may make a little bit more sense. So basically I've replaced y with x cubed, and then basically y squared plus 7y minus 8 is basically a quadratic which I can solve. When I've solved for y, remember we need to go back here and realise that y is actually equal to x cubed and solve it that way. So let's carry on with this method. So what can I do with this quadratic I've got in terms of y? Can I factorise it to find the roots? I could complete the square if I wanted to, or use the quadratic equation. Let's try factorising first. So two numbers that multiply to give me -8 and add to give me 7. So it's going to be 1 and 8 that I'm going to use, not 2 and 4. How can I make 1 and 8 give me plus 7. Well, by having negative 1 and 8, and that multiplies to give me negative 8, so that works. So then what I will have is in brackets y minus 1, and then y plus 8 is equal to 0. I can easily find the roots of that. So the roots will be y equals 1 and y equals negative 8. However, we haven't finished. We've only worked out what y is. We need to work out what x is. So from here, if y is 1, that means that x cubed is 1. What can we do? We can solve that, find the cube root of both sides. That will give me x is equal to 1. Okay, how about when y is negative 8? Well, when y is negative 8, that means x cubed equals negative 8. We can cube root both sides, and that will give me x is equal to negative 2. So now I've solved it for x. So I use that y as like a stepping stone to help me. So anytime you see these equations or expressions where you see that power at the front is double the second power and there's no x on the last term, we can treat it as if it were a quadratic by replacing the x to the power 6 in this case with x cubed, basically whatever the power is there. So if this was x to the power 10 here and this was x to the power 5, I would say let y equal x to the power 5 and get my quadratic, solve my quadratic, but then use those values to find my x values, and then we're done. So you should now be able to do exercise 2E on pages 26 to 27 of the textbook.